A letter A consists of uniform wire of resistance 1 ohm per centimeter. Each side of letter is 20 centimeter long and cross piece in middle is 10 centimeter long. While the apex angle is 60 degree, find the resistance of letter between the ends of the legs. This is, they are giving the 60 degrees. This is the letter. Now we need to find out resistance here. This part resistance, this part resistances. This total length is what? 20 centimeter long. So here to here 10. So this is 10, this is 10 ohm. And this is also 10 ohm. This is also 10 ohm. Then middle cross piece is what? Cross piece in middle is 10 centimeter long. So resistance is 1 ohm per centimeter, means resistance will become as this is also 10 ohm. Then they are asking the effective resistance between A, B they are asking. Now we need to find out resistance between A and B. For that, this circuit I am changing as like this. Here this is A, this is B. This is 10 ohm, this is 10 ohm, this is 10. Then these two are in series. So 10 plus 10, 20 ohm. Now these two are in parallel. Now again circuit will become as like this. Now here this is A, this is B. This is 10, this is 10. Now these two are parallel, that is 1 by 20 R1. What is the parallel resistance formula? R is equals to R1 R2 by R1 plus R2. R is equals to 20 into 10 by 20 plus 10. So R is equals to 200 by 30. So 20 by 3. So this will become as 20 by 3. Now total these three resistors are series. Now R effective between A and B is equals to 10 plus 20 by 3 plus 10. Then what you will get? 3, 30 plus 20 plus 30, which is equals to 80 by 3. RAB is nothing but a 80 by 3, which is equals to what we will get? 3 1 3 2s are 6, 20 is 18.26, 26.6 ohm. RAB is equals to 26.6 ohms we will get. This is the resistance between the legs of the letter A. Here between these 2 points, resistance RAB is equals 26.6 ohms. M number of cells, each of EMF E connected in parallel. How to connect parallel? This is parallel combination. Dash dash M number of cells connected with one external resistor capital R. this is ER, this one is ER, this is EMF and R, EMF and R, this is external resistor. First cell, second, third, dash, m number of cells. This is mth cell. Each of EMF E connected in parallel. Then current in the circuit we need to find out. Current in circuit I is equals, we need to find it. For that, before that, total EMF in the circuit, total EMF in circuit, which is equals E only, because of in parallel combination potential difference is constant, nothing but EMF is constant. So total EMF in circuit is E only. Total internal resistance, total internal resistance is R by M, R by M. Now current I is equals total EMF by total resistance. Clear? I is equals, what is total EMF? E by total resistance, external plus internal, R plus R by M. I is equals ME by MR plus R. When small r greater than capital R, then this is neglected, then we will get as I is equals ME by R. I equals ME by R. If the circuit has only single cell, circuit has only single cell, in that case, if circuit has single cell, then current through the single cell is equals to what we got? Already we know that E by capital R. In that case, again, so this is equation 2, this is equation 1 by 2, that is I by IS is equals ME by R by E by R. Then what we will get? M. I is equals to M into IS. Kirchhoff laws. First law, this is called current law. First law or junction law or current law. Total incoming current to the junction is equals to total outgoing current from the junction. This is incoming current to the junction, I1, I2. This is outgoing current from the junction, that is I3, this is I4, this is I5. This is junction. This is junction. What is first law? Total incoming current is equals to total outgoing current from the junction. Total incoming current to the junction is equals total outgoing current from junction. Total outgoing current from junction. Or algebraic sum of the currents at the junction is 0. Algebraic sum of currents at junction is 0. We can write this is the statement or this is the statement for first law. Total incoming current to the junction is equals total outgoing current from the junction. Algebraic sum of currents at the junction is 0. That is summation I equals 0. Summation I means incoming currents take it as positive, outgoing currents take it as negative. Then I1 plus I2, outgoing current is minus I3 minus I4 minus I5 is equals to 0. Then this total component goes to that side, which is equals to I3 plus I4 plus I5 is nothing but a total incoming current to the junction. Sum of incoming current to the junction is equals to sum of outgoing current from the junction. I1 plus I2 is equals to I3 plus I4 plus I5. What is second law? Total potential difference in a closed circuit is 0. Total potential difference in closed circuit is 0. That is closed circuit, already we know it having some external resistor. This is E, this is R, current is flowing through the circuit. Total potential difference in a closed circuit, here E minus IR equals to 0. Why we are taking minus IR? We will discuss sign conventions. E is equals to IR. Now before doing this one, we will discuss sign conventions. Sign conventions. This positive terminal, negative terminal of the battery, positive terminal, negative terminal. If you travel positive terminal to negative terminal this direction, then we can take it as this is minus E. If you travel negative terminal to positive terminal, then we can take it as this one is plus E. We are traveling positive terminal to negative terminal, then we can take it as minus E EMF. Negative to positive, then we can take it as plus E. The same thing in case of resistor. This is resistor R, this is current direction. This is current direction. If you are moving along the current direction, means you are traveling from this direction along the current direction. This is I, current direction to the resistor. If you are traveling along the current direction, then we can take it as minus IR. If you are traveling opposite to the current direction, this is I, you are traveling this direction, opposite to current direction, then we can take it as plus IR. This is minus IR, this is plus IR. This is called sign conventions. When we are using this one Kirchhoff first law, second law, we need to apply sign conventions. On the sign conventions, we will solve a small circuit. This is resistor, this is EMF. Clear? Now current is passing positive terminal to this direction. This is resistor, this is EMF. Then we are moving negative terminal to positive terminal, here to here. So negative to positive means it is a plus EMF. Now here moving along the current direction, here to here we are moving. So here to here we came, here to here we are moving, so that minus IR is equals to 0. This is the Kirchhoff's second law. Total potential difference in a closed circuit is 0. E minus IR is equals to 0. Then we get as E equals IR. Now we solve some circuits, simple problems on the circuits. This is 1, this is 20 volt, this is 6 ohm, this is 4 ohm, this is 1 ohm, this is E1, this is 1 ohm, this is E2, this one is 2 ohm, this is A, B, C, D. Now find the EMF E1 and E2 in the circuit. What we have to find out? Find E1 and E2 in the circuit we need to find out. So for that, apply the Kirchhoff laws to this circuit and to this circuit. What we have to find out? E1 value and E2 value we have to find out. For that, this I am taking as D dash, this I am taking as C dash. Now current coming from here and similarly current is coming from here. These two are, and current is coming here. So and current is given in the circuit. Here this is 1 ampere, here they are giving as 2 ampere. Now find E1 and E2 we need to find out. Here how many closed loops we can see? This is one closed loop and this is one closed loop. So first apply Kirchhoff's second law for loop A, B, C, D. A, B, C, D. A. Apply for this one. Now, this one, apply for this one. What we will get? Which direction we are moving? A, B, C, D. Here to here, here to here, here to here we are moving. A, B, C, D, A we are moving. So A to B first. Here. What is the current is coming from here? From in this case to 1 ampere, in this case 1 ampere. So totally is 2 ampere is going out. So 1 ampere is coming here. So we are moving opposite to the current direction. A to B we are moving opposite to the current direction. So what we can write here? 4 into 1, this one, plus 1 into 1. Next we are moving positive to negative terminal. So minus E1, next B to C, C to this one, this direction. What is the current? 1 ampere. Current is moving this direction, we are moving current direction. Next plus 20. Next current direction 1 into 1 is equal to 0. Then 4 plus 1 minus E1 minus 6 plus 20 minus 1 equals to 0. Then 20, 24, 25 is 20, 24, 25 minus E1 is minus 6 minus 7 equals to 0. 25 minus 7, 18 minus E1 equals to 0. E1 equals 18 volts. E1 equals 18 volts. Now we got E1 value. Next E2 we need to find out. How to find out E2? Again apply the second law for loop. What is that? A, D dash, C dash, B and A. Apply K law for loop A, D dash, C dash, B, A. Apply here. A to D we are moving, D dash. Now here, what is the current is passing here? 2 ampere. So current direction we are moving. So current direction means minus 2 into 1 minus E2. Next again current direction only we are moving. This direction current is moving. Minus 2 into 2. Next here this is plus E1. Next 1 into current direction we are moving, so that minus 1 into 2 ampere minus 1 into 2, again current direction 4 into 2 is equals to 0. So minus 2 minus E2 minus 4 plus E1 is 18 minus 2 minus 8 equals to 0. Minus 2 minus E2 minus 4 plus 18 minus 4, then what we will get? Minus 2 minus 6 minus 7 plus 4 11. So minus 11 plus 18 is minus E2 is equals to 0. Then 7 is equals to E2. E2 is equals to 7 volt. E1, E2 we got. E1 value is 18 volt, E2 value is 7 volt. This is the way to solve the problems by using the Kirchhoff first law and second law. And next we discuss Wheatstone bridge. Wheatstone bridge. Wheatstone bridge. Wheatstone bridge is used to find unknown resistor resistance. Unknown resistor resistance. Wheatstone bridge is used to find unknown resistor resistance. It has 4 resistors. It has 4 resistors. In that 3 are known resistor, 1 is unknown resistor. Find Wheatstone bridge is used to find unknown resistance, unknown resistor resistance. Wheatstone bridge is used to find unknown resistor resistance. It has 4 resistors. In that 3 are known resistors, 1 is unknown resistor. That unknown resistance we need to find out. Which resistance we want to find out? That is nothing but this one. These 4 resistors connected in the form of a square. These 4 resistors connected in the form of a square. This one. Any two opposite junctions connected to a battery. This is connected to battery, and other 2 opposite junctions connected to galvanometer has resistance G. This is the construction. In this one, PQRS are the 4 resistors. In this 4 resistors PQRS, 3 are known resistors. It may be PQR or PQS or RSQ or RSP, whatever. In these 3 are known resistors, 1 is unknown resistor. Now assume this is unknown resistors, then these 3 are compulsory known resistors. By using these known resistors, we have to find S value. Then current is coming from the battery is I, this is junction. According to first law, incoming current is equals to sum of outgoing currents. I1 is passing, again same thing, IG, this is I3, IG is coming here and I2 is coming here, these two are meet at this point, goes as a I4. Next I4 is coming from here, I3 is coming from here, I goes to battery. This is the construction. Here this is one closed loop, this is one closed loop, we are taking as 3 closed loops. A, B, D, A1 is closed loop and B, C, D, A is one closed loop. By using the loop theorem, that is Kirchhoff's second law, applying first law and second law for this one, then we will get the balancing condition. To balancing condition, we will get the resistances at balancing condition. What is balancing condition here? Balancing condition is nothing but a PQR known, S is unknown in this one. Now by changing PQR randomly, make it galvanometer current is 0. When galvanometer current is 0, when Ig is equals to 0, we can say bridge is balanced condition. Bridge is balanced condition. When galvanometer current is 0, how to get galvanometer current is 0? By changing the known resistors randomly. Then galvanometer, when galvanometer gets 0 current, that time we can say bridge is balanced condition. At bridge is balanced condition, we can write as P by Q equals R by S. Here P by Q is equals to R by S. From here S is equals to, we can write as RQ by P. This is the unknown resistance of resistance. To find unknown resistance of resistance, we assume as S is unknown resistor, PQR is known resistors. Using the known resistors, we got unknown resistor value. That is P by Q is equals to R by S. Here S is equals to RQ by P. RQ by P is the unknown resistor resistance value. This is called Wheatstone bridge balanced condition formula. At balanced condition, P by Q is equals to R by S. This is Wheatstone bridge formula. Here one resistance and middle one resistance is connected. This is 1 ohm, this is 3 ohm, and this is 2 ohm, this is 6 ohm, and this is 5 ohm. Here current is flowing, and current is, this is junction A, this is junction B, this is C, this is D. Then we have to find out effective resistance between A and B. This is the circuit is given. We have to find out RAB we need to find out. Resistance between junctions we need to find out. Already we know when bridge is balanced, the current is passing through this one is 0, then bridge is balanced. When bridge is balanced condition, when bridge is balanced condition, 5 ohm resistor is unaffected. So then we can draw the circuit. Here 1 ohm, here 1 ohm is there, here 3 ohm, here 6 ohm, here 2 ohm is there. This is junction A, this is junction B. Current coming here. Now these two are series connection and these two are series connection. Then series connection of resistances 3 plus 1, it become as 4. This circuit I am taking as like this. Now this is A, this is B. This is 1 3, this is 2 6. Then we can take it as this one, 1 plus 3, 4, 2 plus 6, 8. This is A, B. Now this is 4, this is 8. Now these two are parallel. Now RAB is equals 1 by RAB. Result effective is equals 1 by 4 plus 1 by 8. Then LCM is 8. And finally we will get RAB is equals 8 by 3 ohm. This is the effective resistance between A and B terminal. A and B terminal we will get effective resistance RAB is equals 8 by 3 ohms. This is the way we have to solve the problems by using the Wheatstone bridge. Now we discuss one more problem on the Wheatstone bridge. Like this they are connected. Here they are giving 21 ohm. This is 18. This is 6 ohm. This is X. This is 8 ohm. And this is 3 ohm. Now this is connected to a battery. And this end is connected to a battery. This is C, this is A, this is B, this is D. What they are asking here? They are asking here X value. What is the value of X they are asking? Here 21 ohm resistor is connected, here 18 ohm, here 6 ohm, here X ohm, here 8 and here 3 ohm is connected. Now by using the Kirchhoff law, first we need to solve this one. X and 8 ohm are parallel to each other. These two are parallel. Then by solving that, first effective is equals 1 by X plus 1 by 8 is 8X, 8 plus X. These two combination is 8 plus X, R is equals to 8X by X plus 8. Further 3 ohm is series. Now RBC, which is equals to 8X by X plus 8 plus 3, which is equals to what we can write? x plus 8 is the LCM. Here 8x, this is 3x plus 24, then we will get as 8 plus 3, 11x plus 24 by x plus 8. Now in this case, total this replaced by this one. What is that? 11x plus 24 by x plus 8. Now the circuit redraw is the circuit here connected to battery. Clear? Here resistances, here is 21 and here is 18 and here is 6 ohm and here is, what is that? 11x plus 24 by x plus 8. Now this is B, this is D, this is A, this is C. Now apply the Wheatstone-Bridge formula. What is that? P by Q is equals to R by S. So P is the 21 by Q is a 18, which is equals to R, that is 11x plus 24 by x plus 8 by S. S is what? 6 ohm. Now by solving this one, x value will get as 8 ohm. X value will get as 8 ohm. This is the way to solve this type of circuits. Next, meter bridge. Meter bridge. Meter bridge. This is used to find, it is used to find unknown resistance of a unknown resistor. It works based on Wheatstone-Bridge formula. It works based on Wheatstone-Bridge formula. What is that? P by Q is equals to R by S. It works based on Wheatstone-Bridge formula. P by Q is equals to R by S. It consists of two L-shaped copper strips. These two L-shaped copper strips are connected with 1 meter manganese wire. This is left gap, this is right gap. Here we need to connect resistance box, and here middle terminal is there, that is connected to high resistance to galvanometer terminal to one more terminal to jockey, and here right gap we need to find out which resistance we want to find out, that resistance we need to connect. Here one scale is there downside of the manganese wire, one scale will be there. Meter scale is attached. Now this end is connected to battery positive, this end is connected to battery negative. Battery positive and battery negative. These ends are connected to battery negative and battery positive. This is resistance box, known resistors. This is the resistance we need to find out, that we are connecting in the right side of the gap. Midpoint to high resistor, high resistance to galvanometer, galvanometer to other end terminal to jockey. This is plus, this is minus. This is the initial position of galvanometer. Pointer is like this at 0. When we place the jockey with one switch here, when switch on, when we place the jockey at the right side end, galvanometer should be left side deflections completely. When we place the jockey at the left end, galvanometer should be right side deflections. Then only our circuit working properly. If you not get like this, then just change the polarity of galvanometer. Then when we will get the opposite deflections, means when we place the right end of jockey at the right end, galvanometer deflection is left. When we place the jockey at the left end, galvanometer deflections is right. Then connections working properly. Keep some resistance at the resistance box, some value place it resistance box, and we have to start dragging the jockey on the manganese wire from unknown resistance side, that is right side. From here we have to drag the jockey on the manganese wire. Somewhere we will get the balancing condition, that is galvanometer shows 0 deflections. Galvanometer shows 0 deflections, that is balancing condition of the meter bridge. That length is we have to measure L1, and remaining length is 100 minus L1. This is nothing but a L2. L2 is equals to 100 minus L1. Unknown resistance side we have to measure the balancing length, that is L1. Balancing length means what? When galvanometer shows 0 deflections, that is balancing length. Sorry, balancing condition of the meter bridge. This length is balancing length L1. This is L1, the remaining length is L2, which is nothing but a 100 minus L1. Now apply the Wheatstone bridge formula. What is that? P by Q is equals R by S. Here P is what? This one. Q is this one. This is R, this is S. So here we will get as P by Q is equals to R by S, that is L1 by L2. P is the resistance in resistance box by X, which is equals to R L2 by L1 S. This is L1. Now X is equals to R into L1 by L2. This is the way to find the unknown resistance of the resistance. X is equals to R into L1 by L2. Here L1 is the balancing length from unknown resistance side. L2 is the balancing length from known resistance side. Then apply the Wheatstone bridge formula. X is equals to R into L1 by L2. This is the way to find out the unknown resistance of a resistor by using the meter bridge. Next, potentiometer. Potentiometer is used to compare the EMFs, compare EMF of cells. Next, to find EMF of cell, to find unknown resistance, internal resistance, to find internal resistance of cell. Potentiometer, which is used to compare EMF of cell, to find EMF of cell, to find internal resistance of the cell. First, what is the potentiometer? Potentiometer consists of one battery, ammeter, rheostat, and manganese wire. this is end A, this is B. Now this is the length of manganese wire, This is called primary circuit. This is rheostat, this is ammeter, this one is key, rheostat, and this is called primary circuit. In potentiometer, primary circuit consists of constant current. I is constant in primary circuit. In primary circuit, I is constant. What is the principle of potentiometer? In manganese wire, between any 2 points, potential difference is directly proportional to length between the 2 points. This is the principle of potentiometer. So, potential difference between any 2 points is directly proportional to the length between the 2 points. For example, this is x, this is y is there. So, Vxy is directly proportional to Lxy. So, potential difference between the xy points is directly proportional to length between the 2 points. This is the potentiometer principle. Basing on this, using this, we need to find out EMF of a cell. Now, this is primary circuit. Which cell EMF we want to find out? That cell we need to connect in the secondary circuit with one galvanometer and a jockey. Clear? Now, primary circuit consists of constant current. That current enters into the secondary circuit. That constant current enters into the secondary circuit by dragging the jockey from point A to point B. A to B side. By dragging the jockey from point A to point B side, somewhere we will get the balanced condition. That is, galvanometer shows 0 deflection. And galvanometer shows 0 deflection. That is the balancing condition. When potentiometer is balanced, that length is directly proportional to, where it is balanced, that length is directly proportional to EMF. That length is directly proportional to EMF connected in the secondary circuit. This length is directly proportional to EMF connected in the secondary circuit. This is the to find EMF of a cell by using the potentiometer. And to find to compare EMFs of cells by using potentiometer. Again, same thing, having rheostat, and this is AB, this is primary circuit, this is ammeter, this is battery, this is rheostat. It consists of constant current. Which cells EMFs we want to find out? That cells we have to connect in the secondary circuit by using two-way key with the galvanometer and jockey. First, 1 3 is closed, this is closed, 2 3 open. 1 3 is closed, 2 3 is open. By dragging the jockey, somewhere we will get the balancing length, that is L1, which is directly proportional to E1. Because of current is passing to E1 to this key is closed. So 1 3 is closed, current passes from here, then that balancing length is directly proportional to E1. Next case, 1 3 open, 2 3 closed. Now in this case, current passes from here and passing to 2 3 galvanometer, then E2 directly proportional to L2. First balancing length is directly proportional to E1 when current is passing to here. Second balancing length L2 is directly proportional to this one because of current is passing to E2. Then from 1 by 2, E1 by E2 is equals to L1 by L2. This is the comparison of two cells by using the potentiometer. Next, to find the internal resistance of the cell. To find the internal resistance of the cell. Which cell internal resistance we want to find out? That cell we are connected in the secondary circuit with resistance box and one key and galvanometer and jockey. This is resistance box, some resistance is here working. This is key, this is EMF. In secondary circuit, key K1 is open. This is open means current is passing here, comes to here and passing to the resistance box, come out. So this is open means current cannot come out here. So current passing to this one, then galvanometer is deflected. By dragging the jockey, we will get the balancing length. That balancing length is directly proportional to EMF. First case, when in secondary circuit key K1 is open, when this is open, current cannot come this side. When current cannot come this side, this is unaffected. So only current passing to EMF and this is going to be affected. That's why E is directly proportional to L1. In secondary circuit, key K1 is closed. K1 is closed. That time what is going to be happening? This is closed. Now current passing to here and as well as current passing to the resistance box. Now this is going to be affected in the second case when this became as closed circuit. EMF is closed with one resistance. So this is called closed circuit. When EMF is closed with one external resistor, that time what is going to be worked here? Terminal voltage. Second balancing length which is directly proportional to terminal voltage. Now equation 1 by equation 2, E by V is equals to L1 by L2. But already we know internal resistance R is equals to, already we got the formula, what is that? E by V minus 1 into R. Now R is equals to, E by V is nothing but a L1 by L2 minus 1 into capital R. Here capital R is resistance in the resistance box. This is the formula we are using to find internal resistance by using the potentiometer.